Welcome to this lesson on webhooks versus API requests. We'll explore the fundamental differences between push and pull mechanisms in integrations and how to leverage every HTTP option within Expedify. This session will clarify when to use each tool for optimal workflow automation. Every integration fundamentally boils down to one of two shapes, push or pull. A webhook represents an event-driven push, where an external system notifies you when something happens. Conversely, an API request is an on-demand pull, where you actively ask for information whenever your workflow requires it. This distinction is genuinely simple once framed correctly, and we'll lock it in. A webhook operates as a push mechanism, meaning the sender decides when to initiate the communication. An API request, however, functions as a pull, giving you control over when your workflow asks for data. Webhooks are event-driven, firing instantly when there's news, while API requests are on-demand, running whenever your workflow dictates. Both utilize the same HTTP protocol. The key difference lies in who initiates the interaction. When data flows into Expedify, the Webhook trigger patiently waits at the beginning of a workflow. Once the URL is published and secret is configured, any external system posting to it will fire your workflow. The total requests counter tracks incoming events, demonstrating that you don't control the timing, the sender does. Your role is to react to these incoming push notifications. Outgoing webhooks follow the same push pattern, but with Expedify acting as the sender and you as the receiver. You register your URL and specify the events you're interested in. Whenever one of these events occurs within Expedify, we post the relevant payload to your URL, and your code reacts accordingly. This is still a push, still event-driven, with the arrow simply pointing in the opposite direction. On the pull side, an API request is a versatile node you can integrate into any workflow. When your workflow executes, for any reason, this node initiates a single outbound HTTP request. You have full control over the URL, method, headers, body, and authentication. You decide precisely what data to fetch and when to retrieve it, offering the complete opposite of waiting for an external system to call you. The API request node is organized into three main tabs: Basic, Auth, and Advanced. The Basic tab, where you'll spend most of your time, allows you to define the request URL, which supports template variables for dynamic values. You also specify the HTTP method, headers, query parameters, and, for certain methods, the request body. The node provides two output paths: success for healthy responses and error for issues. The method dropdown offers all the standard HTTP verbs you'll typically use. Get is for reading data, post for creating new resources, put for replacing entire records, delete for removal, and patch for partial updates. You select the method expected by the third-party API, as detailed in their documentation. The form dynamically adjusts. For instance, the request body field appears when you select post, put, or patch. Headers and query params are configured using JSO inputs. For headers, you can set content type, accept, and any custom headers required by the API. Query params allow you to define key-value pairs that Expedify automatically appends to your URL. Both fields feature an expand arrow, which opens a full-screen editor for easier JSO input and variable insertion, enhancing readability and editing convenience. Clicking the expand arrow on any JSO field opens a modal with a spacious editor, making it much easier to read and modify your JSO. Crucially, the insert variable button allows you to seamlessly pull values from upstream nodes and splice them directly into your JSO. This is perfect for dynamically population authorization headers or request body fields with data from previous workflow steps, then simply press Done to save. When you change the HTTP method to post, put, or patch, a request body field becomes visible at the bottom of the form. By default, the content type is JSO, which is the standard for most modern APIs. You can define the body as a JSO object, incorporating template variables directly into the values. This allows the body to act as a dynamic template, populated with data from upstream nodes at runtime. The Auth tab provides a single drop-down to select your authentication type, which then reveals the relevant input fields. Options include none for public endpoints, basic auth for username and password patterns, bearer token for modern token-based authentication, and API key for custom header-based keys. This streamlined approach ensures you provide the correct credentials for each API. Selecting basic auth reveals dedicated fields for username and password. This method uses the traditional HTTP basic authentication pattern. Expedify automatically base 64 encodes these credentials and inserts them into an authorization basic header for every request, eliminating the need for manual formatting. It's commonly used for self-hosted dashboards, internal tools, and some legacy enterprise APIs. For bearer token authentication, you simply paste your token into a single field. Expedify then automatically sends authorization, bearer, your token, with every request. This modern, token-based approach is widely adopted for OAuth access tokens, JWTs, GitHub personal access tokens, and most SaaS-issued tokens. You can also dynamically pipe in a token from an earlier node using a template variable. The API key option provides two fields, API key header and API key value. The header defaults to XAPI key, but you should adjust it to match the specific header name required by the API's documentation, such as XRapidAPI key or a PK. You then paste the actual key into the API key value field. Expedify includes this as a header on every request. The Advanced tab handles crucial operational settings. Timeout in seconds caps the wait time for a response, with 30 seconds as the default. Max retries automatically retries failed requests on 5xx server errors and 429 rate limits with exponential backoff. Follow redirects ensures 301 by 302 redirects are automatically chased. Output mapping allows you to reshape the response, returning only specific fields from a potentially noisy API response. An API request provides several valuable outputs to downstream nodes. The response underscore data is the parsed response body, which can be a JSON object or a string. The status underscore code indicates the HTTP status, such as 200 for success or 404 for not found. Response underscore headers provides the full set of response headers. Runtime underscore miss shows the duration of the call, and success or error paths allow for conditional branching in your workflow. Consider these common scenarios to determine the best tool. For Stripe payments arriving in Expedify, an incoming webhook is ideal as Stripe pushes the data. If a new contact needs to go to your data warehouse, an outgoing webhook is suitable as Expedify pushes the information. For looking up weather or fetching order history mid-workflow, an API request is used because you pull the data on demand. If a source system lacks webhooks, an API request with a scheduler trigger can simulate a push by polling. Real-world integrations often combine both webhooks and API requests. An outgoing webhook might trigger an API request to fetch fuller data when the initial payload is thin. An incoming webhook can be followed by an API request to enrich data from services like Clearbit. You could also schedule an API request to poll a system, then use an outgoing webhook to notify downstream consumers. Effective integrations leverage both tools together. When integrating, always ask, who has the news? If it's an external system, use an incoming webhook. If it's Expedify, an outgoing webhook. Who decides when? If they decide, it's a webhook. If you decide, it's an API request. Do you need data not in the payload? If yes, add an API request after the webhook to fetch it. Remember, event-driven and externally timed means webhook. On-demand and workflow-timed means API request. We've covered the core distinction. Webhooks are event-driven pushes, while API requests are on-demand pulls. Real integrations often combine both for comprehensive solutions. Next, we'll explore how to activate workflows, monitor executions, and debug in production.